everyone, my name is Abby and welcome to This Is My Architecture. I'm joined here by Matt from Buzzfeed. Matt, thanks so much for joining me.
Thanks for having us.
So for those of us that have not been on the internet in the last couple of years, can you tell me a little bit about what Buzzfeed is?
Sure. Buzzfeed is a distributed tech and media company. We publish a wide variety of content from fun cat gifs to serious journalism and also brands like Tasty.
Awesome. So I see there's a lot going on here. Can you tell me a little bit about what you guys have built with AWS and why?
Sure. Buzzfeed engineering culture is all about experimentation. So we wanted to build a platform on top of Amazon services that allowed very rapid, reliable, and safe deployment of our software.
So let's talk deployment. So I'm a user or I'm a developer. I'm sitting in Buzzfeed. I want to get a new feature out. How does that happen?
Right. It all starts in the development environment, which we believe is really important for dev prod parity. So you're a user, you're working locally, you're running your service locally using Docker, you're testing your changes, you're validating them locally, and then when you're ready, you're pushing commits to your branch on GitHub. What that will trigger is a webhook that's sent to our CI system. We're just using Jenkins. It's nothing fancy. And Jenkins, in concert with Docker, will be running some global configuration checks, running some service-specific configuration checks, and then running tests for that service. If all those things pass, we'll get a deployable container image that will be pushed to multiple ECR container registries for redundancy.
So I have my container image, right? So it's passed test. I've built it locally. It's passed my integration servers. It's on ECR. How does that feature get out to production?
We built a platform called Rig. Rig asks for three simple things in order to deploy a container image. It asks for 1, the name of the service, 2, the version that you'd like to deploy, and that comes from the commit that's been pushed up and built through CI, and then 3, the target cluster. Obviously, we're using ECS for our container scheduler, and those target clusters represent a variety of different workloads, including staging and production. So
you tie a commit, so from a local commit to the build on your CI/CD system to the task definition, and then out to the service.
Right.
So it goes all the way through, and there's like a one-to-one map all the way through.
Right, and that's so we can have a unique ID that represents everything about that service from configuration through to code.
And easier to debug.
Yes. If it's the first time that you're deploying a service, Rig is going to do a lot of the heavy lifting for creating a lot of the Amazon resources that are necessary, like, for example, a Route 53 entry, which, along with the ELB, we use as a very crude form of service discovery. Then it's going to go and create the ECS task and service definitions that represent that service within that cluster. And then when that happens, ECS is going to do its magic and deploy that container onto the appropriate host within our cluster of EC2 machines. Obviously, those are in an auto-scaling group within an isolated VPC from the other clusters.
So I see a little mention of Terraform here. How are you using Terraform in your process?
Terraform is used as a tool that we manage our Amazon resources with. So we care a lot about immutability at various aspects of this deployment. So the containers themselves, but also the Amazon machine images that we use to deploy the EC2 machines. So the operators of the system are using Terraform as a tool to define what those resources should look like, and then actually make those changes to those production clusters. So
I think that's it's a really interesting point that you bring up that I think has been a theme the whole time, and that's that you're treating infrastructure and configuration the same as code.
Right. And we also want to make sure that users are abstracted away from those concerns, right? We don't want them thinking about hosts here. We don't want them thinking about having to interact with the underlying Amazon resources. Rig is the glue that ties that all together and gives them a consistent user experience for them to make changes and deploy them.
So if I'm at Buzzfeed, I'm never interacting with my infrastructure directly. I'm defining requirements,
right.
and then Rig is actually taking care of making those changes for me.
Right. Some of the basic Rig service requirements are around how much CPU and memory you want, whether or not you want a load balancer. And if you don't, you might get scheduled to a different set of hosts within the cluster.
Awesome. I see a couple services that we didn't talk about. How are you using RDS and Elasticache?
Because we're using a microservices architecture, often those individual services will have their own data stores. So we also often provision those for a given service separately. So obviously RDS for persistent data storage, and Elasticache, Redis for more ephemeral.
Awesome. So it all starts with Rig deploy, but we've made it all the way from a developer workspace to production, and we've even fit it in a listicle. Matt, thanks so much for joining me. It's been a pleasure. And thanks for watching. This is My Architecture.